In this video, we're going to take a look at another technique for solving quadratic equations, the square root method. The square root method is going to give us a way to solve quadratics that don't factor, but for which we can isolate a squared expression. We'll see that square roots can undo that squaring, but we're going to have to remember that both the positive and the negative square roots are going to matter. Here's how it works. If we have a quadratic equation that we can write in the form x squared equals k, so now we don't need to have 0 on one side, we need to have some number k, then we know that x must be either the positive square root of k or the negative square root of k. Sometimes this is going to lead to complex solutions, and that's okay. The important thing to remember is that this only works in quadratic equations in which the variable appears only once when we simplify it. So if you see your variable written more than once, you're not going to be able to use this method, and we'll have to try one of the other various methods we have for solving quadratics. Let's start with this example, x squared plus 4 equals 12. Our variable is x, and notice it's only written in here once. There's only one x in there. That tells me this is a good candidate for the square root method. What I'm going to do is rewrite this so that I have the square on one side and everything else on the other. So I'm going to subtract 4 from both sides to get x squared is equal to 8. Well, if x squared is equal to 8, then the square root method tells us that x must be plus or minus the square root of 8. We have to account for the negative one, because if I take the negative square root and square it, multiply it by itself, the two negatives make a positive, and I can in fact get back to 8. Now our last thing to do is to use our rules about simplifying radicals in order to simplify this. So we'll look for a perfect square that divides 8. Well, 4 divides 8, so we can write that as 4 times 2. That is the same as the square root of 4 times the square root of 2. So we get as our final answer plus or minus 2 root 2. And if you want to use set notation to write this, you can write this as 2 square roots of 2 and negative 2 square roots of 2 as our solution set. This next example is a little bit different. Here we have x minus 3 squared is equal to negative 4. But notice once again that our variable x only appears in there one time. So that tells me this is a good candidate. And notice our goal is to have a squared expression equal to a number. Well, we do have that. This is our squared expression here. It's not just x squared, but it's something squared. That tells us that we can go ahead and take square roots on both sides. So if we do that, we're going to get that x minus 3 is, again, remembering the plus or minus the square root of negative 4. Now, we want our answer, final answer, to be of the form x equals something, so we're going to add 3 to both sides. So we're going to write this, when I add 3 over here, I'm going to write this as 3 plus or minus the square root of negative 4. Now, the square root of negative 4 can be simplified. The square root of negative 4, we know it has to be an imaginary number because it's negative, but we're going to write this as the square root of negative 1 times the square root of 4. So we get that x is 3 plus or minus, the square root of negative 1 is I, the square root of 4 is 2. So we get 3 plus or minus 2i, which if we use set notation, we can write as 3 plus 2i, 3 minus 2i. All right, one last example. Here we have 2 times x minus 5 squared is equal to 72. Notice once again, our variable, the x, is only showing up in there once. So that tells me this is in fact a good candidate for the square root method. But that squared term, our squared term here, is not all by itself. And an important step in using the square root method is that the squared term has to be by itself. So the problem is this 2 here. We need to get rid of that. Well, it's multiplying the squared term, so we can just divide both sides by 2. I'm rewriting it because I kind of made a mess of it up there. So I'm going to divide both sides by 2. And that's going to give me that x minus 5 squared is equal to 36. Now I can use my square root method. When I do that, I get that x minus 5 is plus or minus the square root of 36. Well, the square root of 36, that's a nice perfect square. So we get that x minus 5 equals 6 plus or minus 6. Then we add 5 to both sides. And we get that x is 5 plus or minus 6. Now, those are like terms, so there is absolutely no reason to leave the answer like that. This means that x is either 5 plus 6 or x is 5 minus 6, which tells us that x is either 11 or x is negative 1. So our solutions are 11 and negative 1. Now, I haven't been checking my answers, but let's go ahead and check this one. So we'll do our check over here. I'm going to check x equals 11. So 2 times 11 minus 5 squared is equal to 2 times 6 squared, which is 2 times 36, which is 72. That one worked. 2 times negative 1 minus 5 squared is equal to 2 times negative 6 squared, but negative 6 squared is still 36 because of the two negatives making a positive, and so we do in fact get 72, and both of our solutions worked. All right, let's summarize the important ideas that we saw in here. The square root method is what we're going to be able to use to solve equations that can be rewritten in either of these two forms, x squared equals a, or x minus some number a all squared is equal to b. When we do that, we can apply square roots to both sides. However, when we do that, we have to remember that when we put the square root in ourselves, we have to include the plus or minus. All right, now that we've got this method done, and hopefully you've taken a look at how to solve by factoring, what's coming next is something called completing the square, and then we're going to learn the quadratic formula to round out our techniques for solving quadratics.